Today we are taking a topic of differentiation. Differentiation, we know that we have various subtopics under differentiation. What we are going to discuss today is logarithmic differentiation, or it is also known as exponential differentiation in few of the books. So the topic which we are taking is logarithmic differentiation. Before understanding what this topic is, we need to understand that when and where to use this topic, like for which category of problems we need to use this topic. So if we talk about two parameters, that is, one is variable and another one is constant. In calculus, we majorly deal with these two. Let me denote variable with capital V and let me denote constant with capital C. And how many combination of problems we can get including these two? We can have variety as much as 4 variety of problems including the variable and constant. It can be a variable power constant, it can be a constant power variable, it can be variable power variable or constant power constant. Example of variable power constant: x power n. Example of constant power variable, we have a power x, e power x. Example of constant power constant, you can give 2 to the power a to the power 2. And then we have variable power variable, we can have x in the base as well as x in the power, or x power sin x. So this category, the third category, is an important one for us. Differentiation of the first one, that is, what is ddx of x power n? It is, we already know, n x power n minus 1. What is ddx of a power x or e power x? A power x is a power x log a base e, and e power x is e power x log e base e. What is ddx of 2 power a or a power 2? We know ddx of constant is 0. Now comes the third category, which is the vital one. Whenever you encounter any problem in which you have base also as the variable and the power also as the variable, we go for logarithmic differentiation. So before getting the concept of logarithmic differentiation, let me discuss what is 3 or 4 fundamental properties of log, which is very vital in this particular case. So let me discuss that. So we'll see properties of logarithm. Number 1, log of a cross b is equal to log a plus log b. Number 2, log of a by b is equal to log of a minus log of b. Third, log of a power b. In this case, this is the third property, and this is what we are going to use in logarithmic differentiation. Log a power b, what happens in this? The power jumps and comes in the front, so it will become b multiplied by log a. And fourth property, whenever you are having the base as well as the element of log, this is the element and this is the base. When you have both base and element of log as same, the log value becomes 1. With whatever we have discussed, I would like to tell you one more thing, that if at all you encounter something like log of a plus b, that is, log being outside and the element is a plus b, you cannot evaluate it further. So we should know that log of a multiplied by b is log a plus log b, but log of a plus b cannot be evaluated as such. And what is the main property which we are going to use in logarithmic differentiation is the third one, the power one. That whenever you have log base power something, that something is going to come in front of the log and log of that element will remain. So it will become the function of b multiplied by log a. So let me begin with taking a simple question. Let me take question number 1. Y is equal to x power x. Find dy upon dx. So we can see what is the function. The function is x power x. We can see the variable in the base as well as in the power. So this belongs to the third category, that is variable power variable. And for third category, I've already said we will use logarithmic differentiation. So how to approach this sum? What we will do is, first of all, we will take log on both sides. So taking log on both sides, what we got? Log of y is equal to log of x power x. So since we are doing a topic of calculus, you should know that in calculus, what is the base of log? It is always natural log, that is log e. Even if you don't write, it is assumed that you are meaning log e only, base e only. So we have taken log e, that is log y base e is equal to log x power x base e. Applying property number third, this is the third property. Whenever you encounter power, the power will jump and come in front. So on the right hand side, if you apply that property, what will happen? This x power x will come in front. It will become x log x. Now we can see on the right hand side we are having two functions. One is x, another one is log x. Now taking dy by dx on both the sides, or differentiating both the sides, what will get? What is the differentiation of log y? It is 1 by y. Since you have the element as y, not as x, so you need to multiply ddx of y. This is as per the chain rule. So we have 1 by y. Since we have encountered log first, it will become 1 by y into ddx of y is equal to x log x. Which rule we are going to apply here? We are going to apply the product rule, that is u into v rule. X ddx of log x plus log x into ddx of x. This is the thing we have got. So we have 1 by y into dy by dx equal to x into, what is ddx of log x? ddx of log x is 1 by x. It is as per the direct formula. Then we have log x. What is ddx of x? ddx of x is 1. So this x and x cancelled off. We got 1 plus log x on the left hand side. And if we keep this dy by dx on the left hand side, sorry, we got 1 plus log x on the right hand side. And if we keep the dy by dx on the left hand side and take this y on the right hand side, so it will become 1 plus log x into y. Now we can substitute the value of y from the given question. The given question was y is equal to x power x. So taking this y and substituting on the final answer, we will get 1 plus log x into x power x. This is the required answer for dy by dx of x power x.